Hello there.
Hello, good afternoon. How are you?
I'm good.
You ready to share your stuff?
Yeah, I could. How much time you like to need to talk?
I don't know. Long enough to convey your message and short enough to not drone on.
Uh,
Uh, that's the answer you always give when a student asks, how long should their paper be?
I'm sorry, I could not hear you much.
Oh, I said that's the answer you give when a student asks how long their paper should be. You say long enough to communicate the message, but short enough to not be too long.
All right, yeah, cool. You can stop me anytime. That's I think that's the good things. I'm flexible. Maybe around 25 minutes.
I think that'll be perfect.
All right. Hi, Dom.
Hey there, Jack. How are you doing?
Good, wonderful to see you.
And I assume you have not been traveling, or have you been to China, Brazil?
Maybe the year after next year. And actually, Matthias just emailed me and said, well, are we going to plan trip to Brazil and China? I said, I don't know yet. I hope so. But China is difficult because you have to be quarantined for 3 to 5 weeks. And
3
yeah.
to 5 weeks. Wow.
Yeah.
Wow.
In some places actually 8 weeks, 28 days plus 28 days. Yeah.
Wow.
Yeah. So one of the students, yeah.
Yeah, the cost
Anyway,
of a
are
zero
we ready
tolerance.
to start getting going? I put the link to the Google Doc in the chat. It's the same Google Doc that's also at the top of the Slack channel and in maybe many other locations. Do we need any more introductions? Anybody new? I see Courtney wasn't unable to join us last time. So Courtney, do you want to say briefly who you are and remind? I don't know.
Sure. Hi, everyone. It's nice to see you. I'm Courtney Flint. I'm at Utah State University with Dave and Jeff, and I am a natural resource social scientist. I'm in a Department of Environment and Society in the College of Natural Resources here. I have a background in geography as well as sociology, but I'm very much on the applied and interdisciplinary sort of fringes with a lot of other earth scientists thinking about sort of complex systems, particularly with regard to water and hazards and vulnerability, as well as well-being. Sort of, I like to look at the glass half full as much as, or more perhaps than the glass half empty, but it's always important to look at vulnerability to try to reduce it. So that's me. And I want to introduce Casey Trout, who is my data analyst and will be very much working on this project with me, at least for this year and hopefully beyond that. So Casey is here as well, Casey Trout.
Yep. Hi, everyone. As Courtney mentioned, I work for her. I've been working for her for the past few years and just started a full-time position with her. So hopefully I'll have time to work on this project a lot and just excited to learn more about what's going on and learn from everyone today.
Welcome.
And she has a degree in environmental studies and statistics and does all my GIS and data stuff for me. So she'll be the bridge to most of the other people. Thank you very much.
Yeah, that's wonderful. Yeah, thank you.
And Shawan has a thumbs up for GIS, I guess. Or data science, or one of them.
Yeah, my ears perked up multiple times as the introduction was going on there.
Okay, I think everybody else has been here fairly recently, but if anybody wants to say anything by way of introduction, I guess there's a chance. Okay, then before we, I guess we agreed last time we met that we were going to have sort of overviews of each other's work to inform each other and start converging on the Science Catalyst ideas. And Jack volunteered to go today, but before he goes, I'm wondering if we should try and schedule somebody for next call, which is 2 weeks time from which is the 2nd of December. And I put a table at the top of our notes, which is very tentative. And Tom said he would enjoy sharing some ideas, but not before December. So I didn't know whether December 2nd was late enough that you could do it, or whether you want us to prefer it later. And then DJ also said he might be able to join Tom. So is December 2nd too soon for you guys, or would you be willing to go then, or anybody else want to do something there?
Iman is critical here as well. He's Iman, what do you think about December 2nd?
It's doable.
DJ?
Yeah, I think so. I'll coordinate with y'all.
Okay, pencil is in.
So that's the pencil is now getting written into black computer ink. And anybody want to pick anybody for the December 9th or December 16 days? Those are the only ones we have this year.
We have multiple folks who are not here, right?
We do have folks that are not here.
Yeah, we might wait a little bit, at least for maybe the next few meetings, to continue to poll, see who might be available.
Well, we should assign the people who are not here to those dates. Isn't that the standard? Okay, well, anyway, we've got December 2nd figured out. So why don't you go ahead, Jack?
All right. Thank you. Let me share my screen. I share the screen now.
Does screen sharing work automatically?
Yes, you are. I think I make Jack a co-host, so he should be fine. And anyone can screen share as well.
Can you see it?
Yep. So good.
Okay, great. So I'm going to talk about something that Tom, Andres, and I have been working for several years now. And so I will talk about some of the work that we have been together and with some other people as well. And also, I'm going to first introduce the framework and then illustrate some applications. And then finally, we'll have discussion related to this project. As you all know, the world is increasingly interconnected. Global shipping network, even for plants like sea, disposal, on flight, go around the world. But in the past, people have done a lot of interaction across distant work, but mainly focus on either environment aspect or social economic aspect. From the environment or climate aspect, a well-known concept is teleconnection. That means climate change in one place can have impact on climate 1,000 miles away. But that mainly focuses on the interaction between natural systems. And then there is another well-known concept of globalization. But that's mainly the social economic interaction between human systems. So for a lot of work that we are interested in now, sustainability, we have to consider both the social economic and the environment together simultaneously. So we needed to have a new perspective, which is to integrate human and natural system together consider both the environment and the socio-economic perspective simultaneously. So here is a new term, relative new term, telecoupling. Tele means distant. Coupling means the interaction between humans and natural systems. And so this is a concept that we have in the paper that I will mention later. That Tom is part of the paper. And we'll talk about socio-economic and the environment interaction between coupled and human natural systems over distance. So before we talk too much about telecoupling, I want to just briefly mention what's coupled human natural systems mean, which is integrated system where humans and natural components interact. So here is an illustration of human systems, different sectors, different stakeholders, they interact across different organization levels. And the human component has impact on natural component, which also has different elements, abiotic, like climate and geographic, hydrological, for example. And the biotic, animals, plants, and microorganisms, and so on and so forth. They also interact across different organization levels. And changes in the natural system could have impact on the human system. That's how the feedback. So that's why we call it couple, just like husband and wife, they have this intimate relationship, not just the one directional impact, but the reciprocal impact on each other. So for telecoupling is an umbrella concept. It is a concept which expand and integrate the concept in different disciplines. So like animal migration, we're all familiar with. A lot of animal species can migrate each year far away, 1,000 miles, some of them. And animal migration has been extensively studied by ecologists, but mainly from the ecological perspective. But animal migration also have enormous impact on social economic systems. And so if we consider both social economic and the environment aspect of animal migration, then animal migration can be treated as a telecoupling process. On the other hand, human migration has been extensively studied by demographers, the economists, and so on and so forth, but mainly from the social economic and demographic perspective. But human migration also has enormous environmental impact. So if we consider both environment and social economic dimension, human migration can be treated as a telecoupling process. The same with trade. And Tom is a leading expert on this, but his background is economics, and then as many other economists studied trade for a long time. And but trade also has a lot of environmental impact. So if we consider trade from both social economic and the environment aspect, then trade can be treated as a telecoupling process too. There are many others, like investment, tourism, knowledge transfer, technology transfer, water transfer, waste transfer, species dispersal, and so on and so forth. They all can be treated or expanded as a telecoupling. So with all those different types of telecoupling process, how can we start them? How can we use a common framework to start it? Animal migration or human migration, trade all have their own framework, but how we can integrate their framework so that we can have a common framework to study all this together. So that's why we need to develop this kind of framework to address both the social, economic, and the environment interactions over distance simultaneously. So that's what we call telecoupling framework. And it has several major components. One is sending system. Sending system in the case of trade is like exporting country to send something out. this is like the flow. And the flow is the movement of people, information, product, good, and financial capital information, and so on and so forth. And the flow got to get somewhere. That's a receiving system. In the case of trade, is importing country. Right? In the case of migration, it's destination of migrant. So the interaction between sending and receiving system is not just the flows from sending to receiving, but also feedback from receiving system to sending system. And then this kind of sending and receiving system have been extensively studied in this distant interaction studies. But there is another type of system which has been relatively overlooked, which is what we call spillover system. Spillover system is a kind of a system affected by the interaction between sending and receiving system. So they are also connected through different flows. And so those kind of interactions, those are three types of major systems. Within each system, we have three components, causes, the reasons behind the flows, why you have this kind of flow, why the reason created, for example. There may be ecological reasons, social economic reasons, political reasons, and so on and so forth. The agents are the decision-making entities that facilitate the flow, like traders, like policymakers, and like farmers produce product for trade, and consumers, buy something, and that will induce trade. And also effects are the consequences, ecological and environmental, social, economic consequences of the flow. So those causes, agents, effects on different systems may be different. There may be something sometimes similar, but work together. Those are the main components of the telecopuling framework. So those are just the conceptual, illustration of the framework. And for details, you can look at this paper that Tom and the other 22 social scientists and the natural scientists work together. And so got this paper, so this is kind of a foundational paper for telecopuling framework. Now I'm going to just illustrate a few applications of the framework. The first one is to a nature reserve for panda conservation. And actually the original idea comes from this nature reserve. So I'm going to use this as an illustration. So this is a nature reserve in southwest part of China. It's a nature reserve for panda conservation, as mentioned. And it has very complex topography, ranging from 1,200 meters to more than 6,000 meters, indicated by different colors. Established in 1975, it's one of the largest nature reserves for panda conservation. This reserve has about 10% of wild pandas in it, and also has local residents. So those local residents and the panda habitat and interact, so constitute a nice couple of human natural systems. So there are a lot of telecouplings going on between Onan and the rest of the world. And because many people in the reserve, actually most of people in the reserve are farmers. They produce agricultural products. They send the product out to the external market. And to produce agricultural product, they have to buy industrial products like fertilizers and so on and so forth. And also the information about pandas and other things about Onan will be disseminated to the rest of the world through news media like New York Times and other outlets. And the government and the international organization also provide subsidies for conservation inside the reserve. And then pandas inside the reserve, not just the wild pandas, but also the pandas in the breeding center, are sent out to zoos in many parts of the world, like Washington, D.C. And many people from outside of the world come to Onan as a tourist to see the pandas and the landscape. So there are many others as well. Here are just a few examples. To illustrate the framework component, I'm going to use Panda loan as an example. And Panda loan the process of loan the pandas from owner to zoos. Each year, the zoo would pay like $1 million for a pair of pandas. And usually it's about 10 years. Right? And then the number of pandas living in zoos outside owner increased dramatically all the time. And this is a picture when President Clinton was still in the White House, and his daughter went to see the zoo, the pandas in Washington. And in the term of the framework, we have a sending system, which is owner, right? Because we send pandas out. Receiving system are zoos in China and some other countries as well. Each dot means the number of pandas there. And spillover systems are places that which have no pandas, but they may go, some people in those places may go to see the pandas there. Like people in Michigan, in Indiana, in other places, Illinois may go to Washington Zoo to see the pandas. So Michigan would be, Indiana or other places would be treated as a spillover system. So now I'm going to just give you an example why this kind of telecopuling perspective is needed. And this is a traditional perspective of panda loan. Basically, is to transport pandas from owner from the nearby airport, Chengdu Airport, to Edinburgh Zoo, which also has pandas, right? Sending system, receiving system. Seems like a simple, an airplane carry a pair of pandas going from owner to Edinburgh. But from the telecopuling perspective, it's much more complex. And actually, the airplane FedEx originated in Memphis, Tennessee, and they made a stop in Anchorage to get some more fuel. And then from Alaska, they flew to Chengdu. And then at Chengdu, they stop and get the pandas on board and then drop the pandas in Edinburgh. But that's not the end of the story. The airplane had to go back to Memphis. So from here to here, this kind of spillover system. And even though they are not involved in sending a panda or receiving a panda. So this process also emit more CO2. That's a kind of spillover effect. So there are also many agents. I'm not going to details here, except I'm going to say is that the agents are the organizations and people that make panda loan possible. And then also the causes. There are many causes, cultural reasons. People are fascinated with the pandas, technology reasons, broad interest in scientific research on pandas by people in the zoo. And there also improvement in the management of panda population in captivity. You increase the number of pandas, so you have pandas for long. And then there are also economic reasons and political reasons, and also effects. There are socio-economic effects, the cost of keeping the pandas in the zoos, and also the visitor pay the entrance fee that will generate revenue for the zoos to pay for the loan, and also improve social networks for scientific collaboration. There are also environmental impact, and the positive impact is to increase the awareness of panda conservation in sending and receiving spillover systems. But the downside is the CO2 emission of transporting pandas or people going to zoo to see the pandas will emit CO2. And also the feedback. So some of the money from the loan have been used for conservation for in the sending system. So those are just the example of how can we apply this framework to real situation. So next application I'm going to illustrate is a collaboration with Tom and others apply the framework to land use and food security. And as you all know, global food security is not just the food production issue. And food needs were usually in the past made by local producers, but now increasingly made through global trade. And also the land use change and in response to the new powerful forces like food demand and import from distant places. But still, we don't know a lot of those kind of complex issues, and especially the social, economic, and environmental interactions across space. And so that's why we wrote a proposal together to understand how soybean trade have impact on social, economic aspect and the environment aspect. Here is an example, a diagram from our proposal indicate the soybean export from Brazil to China increased exponentially over the last several decades. And here is another conceptual diagram from our proposal, indicate the sending system, which is Brazil, receiving system is China in terms of soybean. Spillover system could be US and other places around the world too, because the US is a major soybean production country. And when Brazil increased the production, that created a competition with the US. So when China buys soybean from Brazil, China also, of course, pay money. This is the financial capital that's indicated by M. And then the framework is not just the national, international level, but also can be applied to regional and local level, and the state level, province level, or even the county level. So those different processes can be studied from the very fine scale, from farm, household to global level. And here is just a diagram show the flow of soybean and the flow of fertilizer, because Brazil to produce soybean need a lot of fertilizer. So a lot of countries like Canada and Russia, Germany, they are not, getting soybean from Brazil, but they provide fertilizer to Brazil to produce soybean. So those countries can be treated as spillover countries because they are affected by the soybean trade between Brazil and China, Brazil and some European countries. Okay. Another type of spillover system is that the international supply chain agreement to protect the forest in the Amazon area in Brazil. And they actually reduced the deforestation in the Amazon, like the parent state. And this is but the increased deforestation in another state, which is Cerrado in here, Arkansas. So that's kind of spillover because the Cerrado biome, another biodiversity hotspot, which actually is a major area that we will be interested in this part, for this part. And the deforestation in the Cerrado increased as a result of the supply chain agreement to protect the tropical forest in the Amazon. So that's a kind of a spillover effect. So this is just showing that without this agreement, the deforestation area will be much smaller than with the agreement. And this is in the Cerrado area. This is in the Amazon area, the power state. And so without the agreement, then the deforestation in the Amazon will be much higher than with the agreement. So one of the ways that we do research, trying to understand and quantify the Telecopuling framework is through modeling. One type of model is called agent-based model. Agent-based model have been widely used by a lot of people, but mainly focus on one place. And the agent-based models are basically computational tools to study the interaction between agents like farmers and the environment. So in this diagram, show that their interactions and will lead to changes in learning. So for telecoupled systems, we have developed a kind of a telecoupled agent-based model. So instead of just focus on one system, we consider both sending system, in this case Brazil, and receiving system in China or soybean. And then they have different agents, and the government agents, local trade agents, and the farmers agents. They interact, and also through international trade agents. And then those agents interact with the agents in the receiving system. Right? So the flows are mainly financial flow and the soybean flow. So this is kind of interface of the telecoupled agent-based model. I'm not going to the details. If you are interested more, there are 2 papers published on one on the design of the telecoupled agent-based model. Another is the implementation of the telecoupled agent model. So now I'm going to just briefly talk about the application of the framework to understand the environmental impact. So in international trade, with a conventional wisdom, say importing countries gain environment benefit because they don't use land and water to produce a product. And while exporting countries suffer environmental problems by using the land, by using water, and to produce product, because air pollution and water pollution and so on. So by using the telecoupling framework to generate a hypothesis, saying that actually importing country or receiving system could also suffer from the environment problem of trade. Here is just a map, come from a paper that a former postdoc and did to analyze this global soybean trade. We chose top 10 receiving countries of soybean export from Brazil and the US. And then you can see also the distribution of meta-analysis data on soybean, on wheat, on corn, and rice, and vegetables. So this is the different colors indicate the different types of crops. And these different colors here, the flow, the soybean export from US in red, soybean export from Brazil in blue. And then one thing that we try to compare is the per hectare nitrogen balance among different types of crops. So nitrogen balance is a good indicator of environmental impact of nitrogen pollution. Because if you have too much nitrogen in the soil, then you will pollute the soil. And so for a soybean, it's negative. That means because the soybean can fix nitrogen themselves. And for other crops, wheat, corn, rice, and vegetable, they all have positive nitrogen balance. That means they have excess nitrogen in the soil. So when we have soybean import, then you force the importing country change their land use. A lot of countries actually convert the soybean land to other types of crops like wheat, corn, rice, and vegetables. So after the land conversion, then the nitrogen balance change. Even for soybean to wheat, the nitrogen balance is also positive. Soybean to vegetable, the increase is the highest. So we analyze this environmental impact in the term of soybean area change and also the net nitrogen balance. This top 10 importing countries. China changed the soybean area most. 1.7 million hectares were converted from soybean land to other land during 2010 to 2014. So the net nitrogen balance also changed a lot, more than 1,200 thousand pounds. So most of the country had this kind of similar consequence, except a few small countries had increased the soybean production in their country. But overall, if you consider all the countries together, then you have more positive net nitrogen balance. That means you have more nitrogen pollution in those countries. So the conclusion is that this kind of conventional wisdom is not holding anymore because of this kind of result. Okay. So next I'm going to quickly illustrate the application of the framework to Sustainable Development Goals. And here is a diagram showing that the impact of international trade on SDG target in developed and developing countries. And here the scores, the higher the better. And this is over the years. And as we can see here, with trade, developed country had highest score. And without trade, the developed country had lowest score. Right? This is kind of scenario analysis. But developing country with trade actually will lower the score. Without trade, the score was higher until 2006. So this demonstrates and consistent with what we have been understanding is that the imports from export from the developing countries have impact on the SDG scores in developing countries. So there are a lot of benefits of telecoupling research. One is to help us identify the knowledge gaps. If we compare the components, then we know what has been done, what needs to be done, and the knowledge gap. Also detect the hidden phenomena, especially the spillover effects. And also understand the both social, economic, and environment interactions and the trade-offs, synergies, and sustainability across multiple systems instead of just one system. And facilitate studies on interrelationship among multiple types of interactions, not just trade, but also other aspects, investment and so on and so forth, and help us develop more effective policy and the management of telecarbon systems. There are, of course, many challenges. The waste is more complex, need more resources, time, money, expertise, and need for more coordination among different systems. But also there are many opportunities. And here just to show international interest. Global Land Program has designated telecarbon as research priority. Even this year's Nobel Prize Summit has featured the telecarbon. A lot of United Nations reports have featured telecarbon too. European Commission has a new PhD program in telecarbon. And also a lot of international recognition on telecarbon publications and research as well. And media coverage, like Time Magazine, reports that the new science of telecarbon show just how connected the world is, for better or for worse. And also the UN high-level officials write articles about telecarbon. This is a opinion piece started with telecarbon, why your choice matters for the planet, by the two high-level UN officials. There are many things that we need to understand because the impact, for example, of telecarbon on different systems may be different. And a lot of times it's a mix of positive or negative impact. It's not all positive or not all negative, but a lot of times they may be positive in one system, maybe negative in another system. And then the net outcome is unknown. So there are a lot of opportunities, room for us to study. And one way to start them is to develop this kind of toolbox. And here is just a preliminary set of toolbox, but much more need to be developed and applied. And so there are a lot of people and the agency need to be acknowledged, including numerous collaborators, Tom, as I mentioned earlier, and Andres, and so on and so forth. And also for those who are interested in more publications and so on, can visit the website, easy to remember, telecopuling.org. Right? So I will stop here, but put this diagram on from the proposal that led by Joan and telecopuling cascading impact of natural disaster, land use, and international trade. So in our case, it's not straight, and it has multiple cascading impact from a natural disaster in the US to the impact on biodiversity in Brazil. So there are a lot of interesting things can be done. So I will stop here. So any question that you have?
Thank you. Questions? I'll ask a question just to kick it off, but I hope I'm not the only one asking questions. There's a lot of information there, and I guess you showed sort of early on an example where it seemed like you had agent-based models doing some of it. But once you get to a system that's kind of like what you illustrated at the end, where there's so many interactions, how do we keep it manageable? And I guess what are the cyber infrastructure needs that are going to drive the other teams on this project to sort of keep it manageable, I guess?
Yeah, I think that's something that we can talk a lot about, how to implement this. I think this has become more and more common. And so we needed to take a stepwise approach. So how this impact here will have, like the human activity, land use, like the green stormwater infrastructure have impact on the drought and on flood, for example. Right? And so have good understanding of those, and then how the drought and flood affect the production of soybean. That's another step. And then how the production of soybean and affect the price on the international market through international trade. That's where I can see the expertise of time and others can come in. How this lead to that, and then how that price change will induce the change in the decision making by the farmers in Brazil. How they respond to the price change in the international market. And then their decision making will change the land use in Brazil. And whether they use existing land for more production or develop new land for more production. So I think that's another issue. So I think we can take a step-by-step approach and then connect them, integrate them. And so rather than as a black box, I think we can take a process-based approach to really understand the mechanism and each step. So that's, I think, the expertise of our team can really make huge impact, because some people are really the leading expert on drought and the floods, and some people are expert on production. Some are the expert on trade. Some are the expert on land use and biodiversity, and we also have some international collaborators. And we may also invite other people that we don't have expertise yet. We participate. So I think that's something that I would like to see happen to understand the mechanism step by step. And if we can understand the causal relationship, that even better. If not, at least we have the correlation figured out, rather than just a black box input and output. So I think understand the mechanism process can help us to provide useful and more informative information for decision making.
Okay. Anybody else with questions or thoughts?
Well, I think my one thought about what Jack just said is that we will, through that step-by-step process, we'll have to be very careful to not end up going down the same kind of stovepiping issues that, you know, he talked about at the beginning, in terms of like, you know, it can be very easy to veer off either, you know, doing a more, you know, environmental process part and the more human environment part. So just having to make sure to be very careful to keep those things connected all along the way, because otherwise it could be very, because based on people's comfort zones, let alone anything else, can just be easier for it to split off. So we'd have to be very conscious about how to do that.
Yeah, that's something I think we need to discuss more. One of the suggestions I made during the earlier meeting is to develop more detailed plan, and to how one piece of work can be connected to the other piece of work, and then to the rest of the work. And I think that's hugely important. Have more detailed conceptual diagram will help guide us to implement the part.
So Courtney's got a hand up.
Yeah, thanks. It's great. I've read this, but it's really wonderful to see the presentation sort of pulling this all together. Thank you. I'm just curious about, seems like this is being discussed mostly at a very global scale. But what about sort of regional or even more local telecoupling? So, you know, is this something that's being explored at different scales, or is this truly really only being discussed in terms of global interactions?
Yeah, that's an excellent question. Actually, the framework can be applied at any scale, the local scale as well. And actually, Tom and I have an ongoing project, and let me see if I can find that diagram. And to show that diagram, show the multiple scale application of the framework. So let me see if I have that diagram or not. Okay. Don't see here, but I can find that diagram. So basically, the distance is relative. Right? So I think that's something that we need to keep in mind. We did not define a fixed distance, and that's by design. It's just like an ecosystem. An ecosystem can be as large as the whole Earth, or can be as small as a drop of water. So that helps provide a lot of flexibility for understanding those kind of issues. And okay, here I'm going to show you this diagram.
We've got quite a few hands up, so I don't know if you want to
just
show the diagram or.
I'm going to show this diagram. Just a second. Can you see it?
Yep.
Okay. So this is from our proposal, the ongoing proposal. So this is applied the metacoupling. I'm trying not to give you two new terms, but basically you can treat it as a telecoupling too, right? So metacoupling consists of telecoupling. Metacoupling also consists this pericoupling means the interaction between adjacent systems. There is another concept that we call intracoupling. Intracoupling means human nature interaction within a system. Pericoupling means a human nature interaction between adjacent systems, and telecoupling between distant systems, right? So here is expansion of our telecoupling project. I just showed you a diagram. And here, like in Brazil, for example, at the national, international level, we have telecoupling. They trade between Brazil and China, and also Brazil send soybean to other distant countries like in Europe, and but also send some soybean to adjacent countries. And some of the soybean actually be used by people within Brazil. Right? That's kind of intro coupling. China, the same thing. And then we can also go down to the local level. You have local case and the state level, like Mato Grosso, to produce soybean, you need a label. Some of the label come within the state, some of the label come from other state, distant state, that's the kind of telecoupling, or from adjacent state, that's pericoupling. At the county level or city level, also you have the same thing. So basically you can apply the framework anywhere, any scale.
Okay. So I think DJ's hand was up next.
Yeah, thanks. I appreciate the presentation, Jack. Very interesting. So it seems like from some of the examples that you gave, like there are a lot of different ways that these studies could be carried out. And so I'm wondering if there's any guidance on doing it consistently across, some studies that may be observational, looking at what actually happened in the world, other studies that are done using modeling, CGE models or things like that. And it's particularly dealing with two things. One, identifying what impacts are included or excluded, and then also identifying causality and kind of attributional estimates. Because, like, for example, in the soybeans in Brazil example and imports to China, how do you decouple how much of the change in production in Brazil was causing changes around the world versus how much those changes around the world were caused by exogenous changes in demand for soybeans or weather patterns that ruined production in parts of the world certain years and all of these other things, because it seems like the big takeaway of this is that everything is connected. And so how do you disentangle the kind of web of causality of whether one thing was affected by Brazil increasing their production or if it was caused by something else?
Right, that's an excellent question. Right? I don't have an answer yet, but that's, I think, the hope that I'm hope to collaborate with you guys to work on this issue, because so far the framework, consider all this. When we develop the framework, consider this causal relationship. That's why we have causes there, effects there, and then also other components like agents, facilitate, and the flows, and so on and so forth. So I think the combination of observation, modeling, or even experiment will really help us to tease out those kind of causal relationship. That's the most challenging part. This year's Nobel Prize winners are awarded due to their work on causal relationships. I think maybe if we can figure out that we can get a mini Nobel Prize, right? Not the real one, but
well, if we get a Nobel Prize out of this project, NSF will be happy with us.
Right. Yeah. Right. That's what we are hoping. Tom will, go to the Stockholm to get the prize. That I think that's the something that I think is very important. But I think it needed a combination of tools. Another thing that we're trying to do is develop those tools to understand the mechanism and to also simulate. Sometimes the simulation can help us to, you may not be able to do experiment at the global level, but you can develop a model. You can fix some of the parameters and then run simulation on the changes of some of the parameter values. That you can tease out. It's just like a experiment factorial design. You can have different changes under different scenarios.
Okay, so Manu, you had your hand up and then you took it down. Do you want to ask a question or did you pass?
I'll pass. It'll take way too long given the amount of time that's left.
Okay, all right. Anand, I think you were next.
Yeah, maybe it's a quick one or it can be taken offline, but I'm wearing my cyber infrastructure hat on, and I guess it's follow up with David's question here. I imagine this kind of telecoupling depends a lot on data sets and the large amounts of data sets that we have. Is there, do we have a set of data sets that have been identified which are challenging, or models, for example, maybe that use certain data sets that could be identified that our cyber infrastructure team can start kind of taking and say, hey, making this available so that you can do your science kind of. So many, phrasing it other way, how can we help you from the cyber infrastructure side of things?
Yeah, so I think that's something for discussion among the whole team. I think different components of the work may need different types of help. And for some, maybe the data. For others, maybe the methods, and for the models, and so on and so forth. So I think that's something we need to look into it, how to connect not just the different components of our team, but also with other teams.
Okay. Thanks. So I guess there's been a little bit of conversation and chat from Venkatesh with a question that he doesn't think will come before 3 o'clock and we have to finish. We are approaching the end. Shawen, you've got your hand up. Maybe you get the last few words or question. Go ahead.
Yeah, the discussion there, Anand initiated, Jack commented, actually is a good segue to a few points I want to make. But first of all, very nice presentation, Jack. I read a good number of your papers, but this one is really overarching frame, getting, I think folks really understand what's the gist of telecoupling. But my suggestions / comments, maybe I got 3 here. One is related to the question Anand posed. I'm imagining a data coupling framework, meaning in the context of telecoupling, for the subsystems and the components, we could sketch how data flow across these different systems and the different data requirements and transformations happening. So you could imagine this forms network as well, but it directly couple understanding of data needs and possible even analysis transformation associated to your telecoupling framework. So I would encourage this to be perhaps pursued by our grad students and even Iman, getting to the nitty-gritty aspects of how to connect the data aspects with this telecoupling nice conceptual framework. So that's one. The next one, I think it's obvious to me, at least, at a high level, the telecoupling framework is a good match to network analysis. You mentioned agent-based modeling, which is a more process-based approach, but the network, especially at a multi-scale representation level, seems to demand network analytics. So I would encourage us to point to that area in case we need, expertise. We should dig more network science, network analytics. So the third comment is more on the science question side. I remember we discussed this when we prepared the proposal, but just throw out here, since we're recording this, with all the nice examples and also literature in the context of telecoupling, the kind of shocks, the systems getting shocks like major disasters, floods or droughts, and how this sort of percolating across telecoupled systems, that seems to be still a frontier. If this could be confirmed by this group, especially from Jack, I would encourage us to have a major focus on that. Because understanding these shocks to interconnected systems through telecoupling might be scientifically quite a novel thing. And if we could take concerted actions addressing this gap in the scientific work, particularly through the telecoupling framework, that might be our initial sort of scientific, focus from generating a few questions related to that.
Yeah, those are excellent comments and suggestions. Actually, I totally agree. And I saw Tom put a chat message there. So he will talk about more specifics about data and the scale and offer a wish list next time. In terms of network analysis, actually, there are a number of studies, including ours, have used network analysis to understand the telecoupled system. And I just sent a link to a paper that we just published in Nature Sustainability using network analysis to understand how the water ecosystem service and the city relationship. And also another a number of other papers use social network analysis in the international trade of using the telecoupling framework. So in terms of the scientific issues, I think that's exactly. I think this is something that very excites me to tease out the complex relationships. Not a lot of things are not direct impact, maybe indirect impact. That's cascading effects. How can we go from state A to state to point B? Maybe we have to go through 10 steps to get to from A to B, but eventually we get there. That's why the complex and the indirect impact will be hugely essential for us to understand. Those kind of hidden or invisible impact will be uncovered.
So I want to kind of be respectful of folks' time. I think with this sort of topic, it could be never ending. So, and I see Tom has to run. So yeah. I'm going to suggest we cut it off. Tom and DJ and Iman are presenting next time. Please think about your ideas, perhaps sponsored from, perhaps catalyzed by what Jack has just said, and think about the shocks that are resulting. And there was a bit of chat with Courtney actually asking what the context was, and I put an answer in there. So look at the answer that I put in chat, which related to Anand's point about cyber infrastructure. And then as we talk about a lot of terms like network analysis, like metacoupling, as we go ahead, I'd try and encourage us to sort of try and make them specific, because we're dealing with a lot of people that don't know many of these things. So maybe we should leave it at that and look forward to Tom and company's presentation next time. Thanks.
Okay. Thank you all for your time and attention. Yeah. Happy Thanksgiving.
Happy Thanksgiving, everybody. Yeah.
Yeah.
No call next week, but we've got 2 weeks.
All right. Okay. Good. Thank you, Dave, for organizing.
Happy holiday.
Yeah. Bye.
All right. So Becky, I'll get to the room for our meeting soon.